Hi guys. So, I want to talk to you for a minute about reducing almost any function with one parameter to an O of 1 problem. And the way we do that is simply by storing all the values in a table. So let's say we want to do something like sine of x. You're all familiar with that. Okay, now, if we go to Wikipedia, and I probably should have done this in advance, but what the heck. Okay, so we'll go to Wikipedia, and we want to get the formula for sine x. Some of you may have heard of that. Trigonometric functions. Okay, so what we can do, is you can express a lot of these formulas as sums. So, here, right now, for example, sine of x is this series. X minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, and so on and so forth, or cosine. And so the idea is you keep going until the factorial gets too big to be important, which basically probably it's not too far actually, but still there's a lot of powers and factorials and stuff to do. And as a general rule, even though it's probably O of 1, it's still sort of messy. Easier, just store it, right? So the idea is, you have sine of x, let's say we have a single position 32-bit floating point number. Well, that's, there's 2 to the 32 of them. So we just need a table with that has 2 to the 32 entries of 4 bytes each. So that would be 2 to the 34th, or 16 let's see, 2 to the 34th is 16 gigabytes, which once would be crazy, but isn't anymore. You can just store, and then you just look it up in an array, 16 gigabytes long. Now, sometimes if you want to, now, let's say though, there's a lot of numbers but you won't want all those 32-bit numbers, right? There's a few numbers that you're going to use a lot, like the ones with integer degrees. And then there's a lot of them that you don't need to store in a table. And so we can use tables to reduce anything that's that's been calculated before to O of 1, simply by store in a map. Okay. And we've discussed maps a little. The key will be the parameters of the function. So now we can have a multiple parameter function. So the key will be the parameter values, and the value will be the computation. So no matter what function, as long as the function can't be time dependent or depend on class variables or other stuff like that. Right? It's got to be dependent only on its parameters. But if a function depends only on its parameters, like a math function, then each time you store it, you take the parameters and you take the value. Then when you want to calculate it, you look it up. Now, the problem is if you want to make a table like that, it'll be a giant array with very few entries. Right? So we can, and that's not a very efficient way to use memory, right? And it's more or less impossible if there's more than one or two parameters. Okay, even the parameters of byte, you can handle up to, you can build an array of 3 or 4 parameters, and you end up 2 to the something or other, like 2 to the 32. By the way, 16 gigabytes has to do with 4. Let me put that in. It might be a little confusing, so we'll call that 4 gigabytes. 4 times 2 to the 32nd. That's 4 times 2 to the 32nd. 4 byte answer, 4 byte floating points, and 2 to the 32nd of them. Okay. Just want to make sure that that was not confusing to now. So instead, we use something else. Now, if we use a linked list, it would be O of n. So what we tend to use is something called a hash table. Now, so the next lecture, that allows, as long as it's big enough, it can handle sparse data entries with average time O of 1. As long as the table is larger than the number of things in it. Its worst case will still be, hash table's worst case is still going to be O of n. But as long as the average and best case, average case is O of 1, we're going to like it, just like we did in the last thing. So the next lecture will be how do hash tables work. Okay? And I'm going to, and I think I'll put that in a separate video.